Welcome. In this screencast, I want to explain some basic principles of Room in a simple example. The example is self-contained and doesn't require any prerequisites except that you should have set up your C toolchain by following the tutorial Getting Started in C. We start with an empty workspace in the C++ perspective. First, we need to create a project using the project wizard. For the eTrice project, we select C and the eTrice C template project. It will create for us three projects, the template project itself, together with the runtime and the model library. So here are the three projects, and there's already an editor open for our template model. First, I want to simplify the model and start pretty much from scratch. We don't need the timer service for our example, and clean up the imports. And then we are left with a very simple structure. The root of every room system is the logical system. The logical system is the container for everything in the system. Logical systems are composed by subsystems. And as Room is an object-oriented language, objects are created from classes. In this case, we have a subsystem ref called subsystem ref of type subsys class. The subsys class is defined here. Subsystems can be regarded as operating system processes, and subsystems are composed of actors. Actors are the basic building blocks of our room system. In our case, we have just one actor, which is defined here as an actor ref top actor of type top actor. The actor class top actor is empty up till now. So we have a very simple structure. We have on top in the root, we have the logical system logsys containing a subsystem ref, and the subsystem ref is containing a top actor. This is the current system structure as a diagram that can be created using the documentation generator. A very important property of actor classes is that they can be viewed as logical machines which can't be interrupted. They might be subject to operating system preemption, but in a logical sense, they run to completion. The rest of our example, we want to show how actors can actually communicate. To this end, we want to add two actors which communicate with each other. One actor class we call foobar, and the second one we call foobar controller. In Room, the only way to communicate for actors is to exchange messages asynchronously. For this purpose, we first have to define a protocol class which defines the messages. We call it foobar protocol class, and it consists of a set of incoming and another set of outgoing messages. As incoming message, we define the command initialize, and as outgoing message, we want to define the response initializing. To make use of this protocol class, we have to add ports to our actor classes. We have to add to the foobar port using our structure editor. In eTrice, the textual model is always the master, but for convenience, there is a diagram editor to edit the so-called structure of an actor class. When it is saved, the textual model is modified for the actor class that has been edited. Now let's start to edit the structure of our foobar actor class. It's an interface port, which we call control, and which is associated with our foobar protocol class. So here we have the point where the previously added protocol class enters the game. It determines the messages that can be sent by the actor using this port. Similar for the foobar controller, where we also need an interface port, foobar, which is associated with the same protocol class. But now for this actors, the incoming and outgoing messages are inversed, and so we need a conjugated port. Now we need to create instances of our actor classes in the system. Currently the system contains logical system, subsystem class and top actor. So we want to add a foobar instance and a foobar controller instance to the top actor. Again, we use the structure editor. Now for the top actor, we add an actor-ref controller of our actor class foobar controller, and another actor-ref foobar of the actor class foobar. And finally, we have to connect the two ports using a binding. After these changes, the system structure now looks like this. We have added two actor instances below our previous top actor. To actually exchange messages between the two actors, we have to add some behavior. Behavior is modeled in Room as finite state machine. We added the behavior using the behavior editor. For our foobar class, we will add a state not initialized and another state initializing. We create the unique initial transition which connects the initial point and the state that the state machine assumes initially. And another one from not initialized to initializing, which is triggered by the message initialize from the port control. So initially when the system starts up, the init transition is traversed and the state not initialized is assumed. When the message initialize is arriving, the state is changed to initializing, and in the entry code of this state, we send the acknowledging message initializing through our port control. Similar, we want to add behavior to the controller class. Again, we need a state. Initializing, we call it. And when entering the state, we want to send the message initialize through our port foobar. We connect the initial state with the initial point, and the behavior is complete. Now everything is in place. we can generate code and build the project. And then we execute it using the launch configuration for Windows. So the system started, and now we are prompted to type quit to exit, which we do, and the system is terminated. In the log, we see a newly created message sequence chart. Which shows that the controller is sending this initialize message. The foo bar is switching from state not initialized to initializing and is sending initializing back to the controller. We visualized what happened in the following small animation. Execution starts by traversing all initial transitions and assuming the initial state. The initializing state of the left-hand side is sending the message initialize, and this message is caught by the transition which fires, and the state initializing is assumed, which is sending back a message initializing to the controller. Thank you for watching.